topic of the day, really. And so the notation for this, the notation for this is this right here. Of course, you guys are all familiar with first derivative notation, like f prime of x, y prime of x, y prime, maybe dy dx. These are all notations that indicate we are finding what we call the first derivative, which is essentially that you've differentiated one time. You found a derivative, and that's what we call the first derivative. And those are the notations. We've done those quite a bit. Second derivative, you might guess, the notation is f double prime, or y double prime of x, or y double prime. Those are all Newton's notations. Leibniz's notation looks a little bit weird. It's d squared y over dx squared. There is a reason for that notation, which we will not go into at this moment, but that's what it is. So to get to the second derivative, what would you guess you have to do? Find the derivative of the first derivative, yeah. So to get from here to here, you just differentiate again. So the second derivative is not like extra complicated. It's just another derivative. You just do it again, and that'll get you to the second derivative. And then to get to the third derivative, you would just differentiate one more time. Notation should make sense here. I will make a little exception to this. So f triple prime of x, y triple prime of x, or just y triple prime. And I'm going to put an extra notation here. As well, you can imagine, like triple prime, maybe if there's like somehow a fourth or fifth derivative, there's a lot of little tick marks. And so there is an alternative notation to this. If you wanted to put this, y parentheses 3, that means third derivative. I'm actually going to clean that notation up a little bit. So it'd be y, wow, maybe turn your phones off before you put them in there. There we go. You are all like way more popular than me. No one wants to contact me that much. Okay, so do you see how that could be handy? Like if you had a 10th derivative to go like 1, 2, 3, 4, all the way up to 10 little tick marks, it's going to be hard to count all those. So if you just put y parentheses 10, the parentheses have to be there. If the parentheses aren't there, what is it? Yeah, like third power. It's like just an exponent. With the parentheses there, it means the third derivative of y. And then Leibniz's notation would be d cubed y over dx cubed. Hopefully that makes sense with the pattern we've already established. Catherine, you had a question. Okay, good deal. Anybody else with a question? Okay. So let's do one of these together. Let's do number 8 together, and then I'll leave the other one up to you. So this notation right here, of course, maybe prior to this morning, maybe you've already seen this, but prior to this morning, you might have looked at that and be like, well, I'm pretty sure that's a derivative, but what's the 2 all about? Now we know that that notation is really asking us to find the second derivative. So in order to find the second derivative, we have to first find the first derivative, yes. So to find the first derivative, we're going to use the power rule 3 times. So maybe be some good practice. Johnny, how about the derivative of the first term?
48x to the 5th power minus 50x.
Keep going, sure. That's fine. 50.
50x to the 4th.
Okay.
15x to the 2nd.
Okay, so Johnny's did a good job with the first derivative there. He just used the power rule 3 times for each of the 3 terms successfully, and he was successful. Do you have any questions? All right, very good. Riley, how about second derivative? I know the numbers get a little bit bigger. Can you handle it?
So like 240 x to the 4th minus 200 x to the 3rd plus 30x.
Perfect. And you got all the arithmetic right. Well done. Okay, so that's the second derivative. And you'll find that there is a lot of meaning, both kind of like analytically as well as practically to the second derivative. So we'll use that quite a bit. If you guys haven't already looked at it, take a look at number 9. Let's see if we can find y triple prime. Y triple prime if y equals 2 minus 2 over x. And if you remember, towards the end of last period, We talked a little bit about the trap that people fall into with things like that second term. Do you see the trap waiting for you?
Yeah.
What is tempting to use?
Quotient.
Quotient rule. That would not be the wisest move here. That would work, but it would not be the wisest move. So consider a little bit of algebra before you start into the derivatives. I'll let you all try it on your own or together for a couple minutes. When you've kind of got this ready to do a derivative, hey guys, we don't want to fall into the quotient rule trap, right?
Yeah.
Hey guys, quiet down, please.
2 minus 2x to the negative 1.
And this is a really good opportunity for us to think about labeling. Notice how I didn't write exactly what you said. I wrote y equals, and you probably did write that too, but all you said was the 2 minus 2x to the negative 1. If you don't label it, it would be so easy to like feel like you just did a derivative because you did do something, but label it, call it y equals, and that's a big hint. It's like, all right, that's not a derivative yet. I'm about to start doing derivatives, and so labeling I think would be good. So Colin, keep going. To get to the third derivative, we obviously got to start with the first derivative. So what'd you get for that?
2x to the negative 2, y prime.
Yep. Now, of course, the first term just drops off because the derivative of a constant is 0, right? Okay, Jackson, keep going off of what Colin started us with.
Okay, so I got after that, never mind, it's just in between things. Negative 4x to the negative.
Very good. Caitlin, why don't you finish this one off?
And then y triple prime equals 12x to the negative 4.
That is perfect. Everybody did a great job. Of course, if you wanted to, you could rewrite this to be 12 over x to the fourth. Certainly nothing wrong with that, and that might be a good move to do, but you can leave it with the negative exponent as well. Any questions? Does that flow pretty well for you? All right, let's keep moving. We're going to do a little reviewing of tangent line stuff. This is kind of the second or third go around with this. I hope that that's an indicator that this is important. So this says, what two things do we need to find the equation of a tangent line? You need the point, and I'm going to say specifically the point of tangency. And then you need the slope, and we find that slope of the tangent line by finding what? The derivative, yeah. So find the derivative. So that's just a little review. We've done that, I think, a couple times. We've at least talked about it a couple times. You're going to find then that number 10 is a little different. A little challenging, perhaps. So read it, check it out. I think this is worth your effort and time. Yeah, calculator is active, but please don't feel like that, oh, the calculator is going to make it all better. You're going to have to do some thinking. The calculator will help, but it won't make all the difference for you. Is way too easy or way too hard? All right, so here we go. It says find the equation of the tangent line to the graph of f of x at the point where f prime of x equals 1. So some things I want to bring out. I think are really, really important where I think in past situations it's been easy just to gloss over things maybe or they just weren't there. But let's keep in mind that the meaning of f of x and the meaning of f prime, while related, they are different. So f of x is referring to the y coordinates of our graph, whatever that is. F prime is not referring to the y coordinates of our graph, though it's referring to the slope of our graph. And so they're both outputs, though, aren't they? Mm-hmm. And don't they both share the same input? They both have an x as an input. So there's a lot going on here, and we'll try to work through all of it. So please take the best notes that you can. Ask questions if something comes up. I know you will. So what we normally get is the point of tangency. We didn't get it here. It's actually kind of part of the process, kind of part of the unknown. But we do know that f prime of x is equal to 1, where we are going to have our point of tangency. So my first thought is, even if you have no idea where to start, my first instinct would be, let's find f prime, right? Even if you have no clue where to start there. I have a little analogy for you. Think of like when you run into these situations where you're kind of stuck and you don't know where to start. I think the trap you fall into is this. Think this through. And I put myself in this category too because I want to do this too. We want to see the end from the beginning. In other words, we want to start and not have done anything and say, oh, if I just do this, this, and this, I'm good. That's a very recipe-like way of doing things, and it doesn't always work. So even though we want to see the very end from the beginning, if you can't, don't stress. Here's what I want you to do. Like if you thought to yourself, I don't know exactly how this is going to end, or all the little steps in between, if you're feeling that way, here's my suggestion. Take a little tiny step in some direction that you're confident in. So my first thought is, hey, it says something about f prime, and there's f of x right there, so maybe I should find f prime. Maybe that would be useful. So I'm going to do that. So I'm going to write f prime of x, and I'll do the power rule a couple times, 4x cubed plus 4x, and I stop. So I just took a little tiny step. Now I don't know if the answer is over there, or if it's over there, or over there, but what I did is I said, I'm going to take a little tiny step in something that I'm confident in. I know that I can do the power rule. Once I'm done with that, will there be another direction that I could go? Do I need to like make a right turn and go this way, or do I kind of keep stepping this way? Make sense? So take little tiny steps and see if they lead you somewhere good, or you might have to make a little course adjustment to get to where you want to go. Okay, so then my next thought is, now that I've written it down instead of just thinking about it, I look and I'm like, whoa, hold on, f prime equals 1, there's f prime. Now I don't know exactly where this is leading yet perhaps, but I do see that f prime and f prime, they're the same, and I know that f prime is 1. Make sense? So maybe you still don't see the end from where you are at, but you do know that those two things are equal, so I would say, well, why not do this? This is kind of the tactic some of you took. You're like, well, those two things are equal to each other, so why not do that? It's true, and it's a little step in a direction. Maybe it'll lead you to a good place. Now, if you can see the end from the beginning, that's great. But if you can't, just keep taking little steps that are true in a direction, and hopefully it'll lead you to a place where you can see the end, or maybe you just end up there and you're like, whoa, I think I'm done. We'll see. Now, this is the step where a lot of you got hung up on. You said, I don't know how to solve that. And frankly, neither do I, at least not using an analytical method. In fact, it's been proven that a degree 5 polynomial or higher does not have a system to solve it. And so this is potentially very difficult. So this is where the calculator came into play. So I'm going to trust you guys on this one. When you solve this using either the intersection feature or the zero finder, depending on if you rearranged it or not, was it like 0.2 something? Give me 3 decimals, please. 0.2367, so I'll go with the 0.237. This is, I want to bring up a point right here. We haven't had a chance to talk about this yet. On the AP test, I try to like train you for this so that when you get to the AP test, it's no big deal. I know if you're a scientist, this might drive you crazy. On the AP test, the standard number of sig figs that we use is 3 decimals to the right of the 0. Every time. So you got to go at least 3. If you go 4, 5, 6, 7, 8, 9, 10, whatever, that's fine. But you have to be accurate to 3. And this is going to hurt some of you. Right here, you're taking your quiz on Wednesday or some test in the future. If this were the answer and you did this, you would lose a point, which is frustrating because that's no indication of your knowledge of the subject. It is an indication that you don't know how to read directions. And so, please, and I will do the same, just so I want to train you for that, right? I want the way that you're going to play the game later to be the same as the way we practice. And so please, please, please do 3 decimals or more. It doesn't really matter to me if you go beyond that, but you got to have at least 3, okay? So 0.237, we used our calculator to solve that. Are we all okay so far? Okay, now we got to understand what this means. This is an x-coordinate. Isn't this something that we're often given at the start? Haven't a lot of these, the one coming up says it, and the one we did before said, like, find the equation of the tangent line when x equals 5. What is that? Well, like, can anybody explain what the meaning of that x equals is? Right, but isn't it half of the point of tangency? Isn't it the x-coordinate? You with me? So here's what I'm thinking. Like, if you didn't know where to start, if you had no idea where to start, you'd say, well, okay, I guess I could find f prime because it is a calculus class, and it does say something about f prime right there. And you're like, whoa, f prime is 1, so why don't I set that equal to each other? How do I solve that? I'll just use my calculator to solve it. Now, here's where maybe for the first time you start to get a glimpse of where this is going. you would look at that and you say x equals 0.237. The hope would be that maybe at this point you would realize that's half of the point of tangency. Okay, now this is starting to feel a little more familiar. How do I find the other half of the point of tangency? You plug in, and let's, so I think we all know what you mean by original. Plug into f of x. Yes, so what I'm going to do, I am going to write f of 0.237. A note here, real important for you. Please don't use the rounded version of 0.237 when you plug in, right? Use the unrounded version off your calculator. So if you want to store it and use it or whatever, or just rewrite it, that's fine. But please don't put in 0.237. You'll potentially be off in your answers. This might be a little different from other math classes too. Excuse me. In the end, your answers have to be exactly the same as mine. So if my answer is 0.235 and yours is 0.238, we don't say close enough, you lose a point. So you need to keep all of your decimals throughout. If anybody doesn't know how to use the store feature on the calculator, come see me real quick right after class or something. I can show it to you. It's super easy and it saves you a lot of time from having to like type in stuff and write stuff down. So I'll be happy to show that to you. Okay, so I'm going to trust you guys on this one. What is f of 0.237? So 0.115, would that be accurate to 3 decimals? Okay, fair enough. So that is the y-coordinate of the point of tangency, and I've got the x-coordinate already. So let's think. The two things we've got to have the point of tangency, which we just completed, as well as the slope of the tangent line. If I have those two things, I just put them together with maybe point slope or something, and I've got it, right? What's the slope of the tangent line? Isn't it 1? Right here. I'm told I'm interested in the place where f prime is 1. So that automatically means the derivative is 1, which means the slope of the tangent line is 1. So I really have no more work to do other than putting it all together. So I'm going to say y minus 0.115 equals 1, parentheses, x minus 0.237, and I'm done. So let's just analyze this from a bigger picture standpoint. The previous problem we did like this, the point of tangency was given to you very plainly. The slope was kind of the challenge. Here, isn't it exactly the opposite? Wasn't the real challenge to find the point of tangency? And the slope was just given to you. The slope is 1. Point of tangency was the harder part. Your brain's getting a little workout this morning? Yes. Okay. Any questions? Honestly, any questions, any what ifs? Whys, hows? Okay. Well, this next one I think you'll find to be a little more tolerable. Check it out. The next one shows up here. I think it's number 11, hopefully. Here we go. Yes. So g of x is right there. Find the equation of the tangent line when x is 2. Then use the tangent line to approximate g of 2.5. Isn't this the more typical look like we had at the start? Like the one we did before? I give you an equation. I give you the part of the point of tangency. We've, proceed from there. So try this out. If you get stuck on the approximating thing, that's fine. We can do that one together. But see if you can take it all the way through to getting the equation of the tangent line. Help you out here, show you what I got. Can have a conversation if we need to. Here we go. So if we are going to be finding the equation of the tangent line, we probably should have the point of tangency. I know that x equals 2 is part of it, so I'm going to write g of 2, because that would be the other half. That would be the y-coordinate that goes with that x-coordinate. So when you plug in a 2, we get, what, 24, 16, 18, 17? Mm-hmm. 17 for g of 2. So that tells me my point of tangency is g of 2 equals 17. I do not have the slope of the tangent line, so I've got to find it. So Josiah, if I'm going to find that, I need to find g prime. Would you run through that real quick, what g prime is? Oh, the whole thing.
Oh, sorry. 9x squared minus 4x plus 1.
Okay, so just doing the power, again, just making sure you're all good with the power rule. And then you plug in a 2, right?
Yeah.
So g prime of 2, when you plug it in, you said 29?
Yeah.
So 36, yep, 29 makes sense. So as far as an equation of the tangent line, did you guys get y minus 17 equals 29 parentheses x minus 2?
Would we have to put G instead of
Nope.
or can we put Y?
You'd want to put y because this is, so like the tangent line is separate from
Oh, right.
G.
It's not actually G.
Exactly. Yep. So, well, the 29 is g prime of 2. So like this equation of the tangent line is a whole separate graph
Is it the second?
from g.
Okay,
Yeah.
that makes sense.
I could draw you a picture of that in a second. Hey guys, we all okay with the tangent line equation? So the third one we've done. Doesn't mean we're perfect yet, but is it starting to make sense? If it doesn't, let me know. Okay, so then as far as the approximation goes, let me sketch you out a real quick picture here. This will probably be less than perfect, but that's okay. What we have is a cubic, and let's just say that the cubic does something like this. And so that would mean, this will be decent, I guess. That would mean that the tangent line would maybe be here, or the point of tangency would be there. Tangent line would look something like that. Slope of 29 is insanely steep, but close enough. Bless you. Is that good? Okay. And so what we have is we have two totally separate graphs here, right? We have the curvy graph and we have the line graph. And so what this is asking us to do now is to use our tangent line to approximate g of 2.5. So do you see how the red line is at least like a so-so okay representation of the curvy graph? At least when you're close to the point of tangency, right? If you move off the point of tangency, it's terrible. But if we're sort of close, it's okay. Make sense? Okay. So here's how we would do this, the second part here. I would say y minus 17 is equal to 29 times 2.5 minus 2. I'm just going to plug that 2.5 into the line, not the curve, because it didn't say what's g of 2.5. If it said what's g of 2.5, you just plug it into the curve for the input and do some arithmetic and you're done. This wanted us to use the line, so we use the line. Of course, 2.5 minus 2 is 0.5. Half of 29 would be 29 halves. So 58, 75 over 2. Did you guys get 37.5? What did I do wrong? Darn it. So half of 29, that's 14.5. So it'd be 29 over 2 plus 34 over 2.
No, it's 14.5 plus 17.
Yeah, so 31.5. Yeah, I was doing the fractions too. I was just, okay, 31.5 makes sense. Okay, so just a quick aside here. What would you guess? Would you guess that approximation of 31.5 is higher or lower than the actual curve's value at 2.5? What would you guess? Lower. It's actually lower. Can you see how the green curve is kind of a concave up looking curve there? So wouldn't the tangent line have to fall below it right around there? That's kind of what we're thinking about out in the future at this point, but that's something else we'd consider. At this point, I just want to see if you can approximate using a tangent line. Okay, I got one more thing I want to do, and you're going to love this part, okay? I hope you all have your calculators with you. We should be in pretty good shape with this. Let me get to it. So motion functions, I'm glad that yours, is yours not charging? You want it.
No, you gave me like a calculator.
Oh, are you serious?
Wait, word.
I'm very sorry. All right, here we go. Hey guys, I want to try to fit this in. You'll be glad that we fit this in. You'll be very, very glad. Here we go. So what is the derivative of position? We talked about this before.
Velocity.
It is a velocity curve. Yep, velocity function. What would you guess then is the derivative of velocity? It is acceleration. That is correct. So that acceleration is how fast velocity is changing. So an example here, it says a car is traveling. Guys, you really want us to get this in. Please focus in. Car is traveling at a rate of 66 feet per second when the brakes are applied. Selected values are given in the table below. V is measured in feet per second. T is measured in seconds. We are asked to approximate A of 2. So what kind of thing is in the table?
Velocity.
Velocity. So how can I relate velocity to acceleration?
You find the slope of the
You find the slope, right? Just like like we said before, the derivative of velocity is acceleration. So if I could find the slope on something having to do with this table, that would allow me then to approximate acceleration. But I want a of 2 specifically. So what interval, what points, what should I use? A of 2 fits where? Right between 1 and 3. Remember that little saying, if you can't differentiate, that's fine. Just do what? Use the secant line. Use the slope of the secant line. So you can't differentiate, and we can't because we don't know what v is, do we? At least not yet. We don't know what v is, so we can't differentiate. That's fine. We'll just use the slope of the secant line. So I will say this. A of 2 is approximately equal to, I'm going to use the secant line slope. So what would the top look like? V of 3 minus V of 1, yeah. So we'll go 26 minus 50 over 3 minus 1. And that gives us negative 24 over 2, which is negative 12 approximately. What kind of units would be attached to that?
feet per second squared.
Feet per second squared is correct. Feet per second is really what that is. Darn it, we didn't get to the cool thing. You're going to be sad you missed out on this when you see it tomorrow. So it's not necessary at all for you to know B to be able to complete your homework, so feel free to complete it. But you will want to make sure that you show up tomorrow. It's going to be a cool trick for you. And if you didn't have your calculator with you today for whatever reason, or if it wasn't charged, it'll serve you well tomorrow morning. Have a good rest of your day.